So it takes the girl.
We also got judges twice.
She's scandalous. She's moved so apparently her son moved. She's a perfect girl. I actually gave her a dress. No, so now this is the actual house. So we're gonna, no, it's so we're gonna get to the address. So you know what's funny too? We have a picture.
Okay, hey, look up. Okay, we had done extra example 3H, so we're going to start with 3 I's. Turn to the blue packet. So blue packet, extra example 3I. Question says find the position of the particle at time equal 3. So that's going to require the fundamental theorem. So, you should write on your paper, if I integrate starting at time 0, I'm starting at time 0 because I know the position at time 0 is equal to 2. I'm going to stop integrating at time 3. I'm going to integrate the velocity. And we're going to do this in pieces to hopefully, again, reinforce the meaning, not just the steps. 2 points. Because they want me to find the position at time 3. Nope, good question. You're good. Okay, so you grab your calculator. 2002 number 3. And you go to main screen, clear that off, Math 9, 0 to 3, integrate the velocity, which is in Y1. .910. So 1.910 does not represent how far the object necessarily traveled, but it does tell me the difference between where the object is at time 0 versus where the object is at time 3. That's why in this drawing I've tried to represent that at time 0, the object that was at location 2. The object moved somehow, but it ended up 1.9 to the right of where it was. So now you know the object is located at location 3.9. Questions about anything? The way you write that down is you say the fundamental theorem tells me, fundamental theorem calculates displacement. The other way to calculate displacement is to simply know the 2 positions. X of 3 and X of 0. Well, we don't know X of 3 at the beginning, but we do know X of 0. So that's what you write on your paper. Then the math simply tells you that if you add 2 to both sides, you have 1.910 plus 2 would have to equal the position of the object at time 3, which means this would end up being, just like on the board there, 3.910 is my position at time 3. Questions about anything?
Why, I don't get it. Step, like the second to last step.
So just me making sure I'm understanding. So you're okay that this integral's value turned out to be 1.910?
Yeah.
Awesome. Are you okay that that means if I were to try and draw a picture over here, I'd say, okay, the object moves along this line. At time equal 0, the object is somewhere. At time equal 3, the object is assumed to be somewhere else because the object moved. And this number tells you how different those two locations are. So the space between those two locations is 1.910. Are you 100% comfortable with that?
Yeah.
Okay. So that's what this equation is saying. Well, wherever the object is, if you subtract from that where it was, you're going to get 1.910. So we're just looking for this number here, like where does the object end up? Well, we know the answer in the end is, 3.910 minus 2. That has to equal 1.910. But the way we found that number is to just work backwards and say, well, let's see, it started at location 2. It moved to the right 1.9, so now it's got to be at location 3.9. That's this sequence. I'm still not sure I'm helping at all, though.
No, that totally
Is that better? Okay, 2 more. Anybody else? Please, Jessica.
How did you know that the 1.9 is for like x of 0, not the x of 3?
2 points. The 1.910 actually is talking about both. It's talking about time 0 and it's talking about time 3. Because it's talking about what happened from one time to another. It's kind of like the picture again is what's most helpful to me. The object is somewhere at time 0. It is somewhere else at time 3.
Okay, yeah, that makes sense.
I'll just keep talking for the video. The value of the integral, 2 for Jessica. The value of the integral is not the location. Everybody look, come on, super critical. The integral never tells you the location. Because like I said to Ethan, the integral isn't talking about a specific time. The integral is talking about time period. So we don't know the location from the integral. What we know from the integral is I'm 1.9 to the right of where I was. But where I was location 2. So on this path, now I've got to be over here at location 3.9. Because I'm 1.9 to the right of where I began. So the integral is not telling me where I am. It's telling me how much my position changed. Other questions? Cool, next one. We're almost pretty much done with the blue now. Number 6 just says at what intervals of time is the particle moving to the left? Give a reason. It's very straightforward. You graph velocity for the time period they give you. You're going to get a graph that looks like the one on the board. You remember that when the velocity is negative, that's the time when the particle is moving to the left. So you simply compute those times using your calculator, you write them down, and then your reason is particles moving left during those time periods because those are the times when the velocity is negative. That's all that's required. Question? Cool. We're pretty much done. I knew we were close. We already talked about how to calculate total distance. Everything else is you can do. Okay, so we're done with the blue. So stop that video.